Okay, here we have section 1.9, which is rational equations. A rational equation is just an equation where you have kind of just a lot of fractions involved, okay? So this is where we will be using those skills that we did when we were simplifying rational expressions. It's going to come into play a lot when we're solving these rational equations. So if you just take a glance down these 2 pages of notes, you'll see that there's a lot of fractions involved, okay? So don't let yourself get overwhelmed. Just take them like one at a time, and just make sure you're paying attention closely to what you're doing for each of these, okay? So there are 2 methods here that you can use to solve these rational equations. Method 1 is by using the proportion, okay? So if you remember, a proportion is basically just 2 fractions that are equal to each other. So this says you can condense it into a proportion, then cross multiply to solve. So we'll do 1 or 2 that way. And then the other method would be using a lowest common denominator. So then you would multiply each side of the equation by the lowest or least common denominator and then solve the equation that way. So basically what you're after first is getting rid of the fraction part, and then you should have a more familiar equation to solve, like a linear equation or a quadratic equation or something like that. Okay, so let's take a look at number 1 here. You can see that this is already a proportion. We have a fraction equal to another fraction. So what we're going to do here is we're just going to cross multiply here, so by the denominator. So if we look at the left side of the equation, we are it's being divided by 10, so we can multiply each side by 10 here, right? And so this will cancel this denominator out, and then we can also multiply each side by 4, and that will cancel the left side out. So this is essentially what you're doing, but an easier way to just represent this is by just saying I'm going to take this denominator and multiply over here, and then take this denominator and multiply it over here. Okay, and so the reason I showed you that we were multiplying each side by 10 and by 4 initially is because I wanted you to see that it was equal, but this is kind of the shortcut way of thinking of it, okay? So let's cross multiply. So we're going to write 4 times v minus 4 on the left, and that is equal to, I guess we can write 10 from the denominator on the side, 10 times v plus 3 here. Now we just have a linear equation, and we can solve this pretty quickly and easily. So we have 4v minus 16 is equal to 10v plus 30. Let's get the v's on the left side, even though that will take us to a negative. And then we'll add 16 to both sides. So we have 4v minus 10v is negative 6v, and then 30 plus 16 is 46, divided by negative 6. We get v is equal to negative, let's see, 46 over 6. I think we can just do that in half, 23 thirds, negative 23 thirds. And that's that one. Okay, so that one was pretty straightforward. Let's try the same method here on number 4. Okay, so let's just take this denominator and we'll multiply over here, and this denominator and multiply over here, and see what happens. So we have the numerator of the left side, 2b minus 5, should be in green. 2b minus 5 times the denominator on the right, which is b plus 6. that is equal to 4b minus 1, the numerator on the right times the denominator on the left times 2. Okay, so we'll have to FOIL here. So the first we have 2b times b is 2b squared. The outer plus 12b inner minus 5b and last minus 30. That is equal to 8b minus 2. Okay, I just distributed that 2 there. Let's combine like terms on the left side. We have 2b squared plus 7b minus 30. That's equal to 8b minus 2. Okay, so we see here that we have a quadratic equation because the degree is 2. So we know that we're either going to have to factor, use the square root method, the quadratic formula, or completing the square. Okay, and for most of these, we want to get everything on the left side anyway. So let's just move everything over to the left side and set it equal to 0. So we're going to have 2b squared, 7b minus 8b. We're going to have minus b, and then negative 30 plus 2 minus 28 there. Okay, just a quick glance at factoring. This looks like it would be pretty simple. Oh, sorry, this is equal to 0. This looks like it would be pretty simple to factor here. Just doing this visually, we're going to have a 2b and a b. And let's see. 7 and 4. If I put 7 here and 4 here, then we'll have a negative 1. Okay. So you'll have to factor this out on your own. I'm just kind of doing it in my head right now. If you can't do this in your head, just do the slip and slide method here. I just wanted to save on time, although it's taking a long time anyway. Okay. Then it'll be plus 7 and minus 4. No, it should be the other way. We want plus 6 and minus 7. Okay, then we're going to set each of these factors equal to 0 to solve. So we have 2b minus 7 is equal to 0. B is equal to positive 7/2. And then we have b minus 4 is equal to 0. B is equal to 4. Sorry, this is b plus 4. B is equal to negative 4. Okay, so that is number 4 there. And let's just do one more. Let's look at number 8, just because this one looks really complicated. So we have been using the proportions method here, where we're just multiplying each side by the other side's denominator, okay? Which is the cross multiply part here. So let's look at using least common denominator here. We'll find a least common denominator and multiply the entire equation by that LCD. Okay, so number 8, our denominators are 6k squared and 6k squared. So our least common denominator here is going to be 6k squared. Okay, because this 1/6, the 6 will go into it if we multiply it by k squared, and the other ones will go into it if we multiply it by 1. So this is the smallest common denominator that we can have. Okay, so we're just going to multiply the entire equation by 6k squared. So when we're multiplying an equation by a number, right, we're multiplying the numerator, but you can also just straight up cancel it out of the denominator. And that's what's going to end up happening here. So when we multiply the entire equation by this, it's the same thing as distributing, right? So we're going to multiply the 1/6 by 6k squared. We're going to multiply this term by 6k squared and also this term. Okay, so what's going to end up happening is we're going to get 6k, it's going to cancel out of these denominators, and then it will cancel out the 6 here, but you'll be left with a k squared term. Okay, so this is just saying we took 1 6 and we multiply it by 6k squared, right? The 6 and the 6 cancel out, we're left with k squared. Okay, on the rest of these, since it cancels out of the denominator entirely, we're just going to be left with what's in the numerator. Okay, so that's what's going to happen here. So let me erase all of this junk going on, and then we'll see our new equation. Let me write it out for you, actually, just in case that was a little confusing. So we said we're multiplying everything by 6k squared, so we're going to have 1 over 6 times 6k squared plus 6k squared times k squared plus 9k plus 20 over 6k squared, and then that is equal to 6k squared times 2k squared plus 11k plus 15 over 6k squared. Okay, so what I did here was I just distributed the 6k to each term, and now you can see maybe more clearly how this is going to go here. We're going to be left with, in this first term, we're just going to be left with k squared. In the second term, we're going to be left with k squared plus 9k plus 20, and I can take that out of parentheses, okay, because we're just adding everything's positive here. And then on the right side of the equation, we have 2k squared plus 11k plus 15. Looks like we have a quadratic equation here. Our degree is 2, so let's just get everything on one side and see what we have left. So we have, well, actually, let's see. We have 2k squared over here. If we minus 2k squared, it's actually going to cancel out, so we're going to be left with the linear equation. We're going to have 9k plus 20 is equal to 11k plus 15. So let's get this, the k's on one side, and then we'll subtract 20. So we have negative 2k is equal to 15 minus 20 is negative 5, so k is equal to 5 halves. We lucked out there, got a linear equation. Pretty simple. Okay, so there's an example of using the least common denominator. So it looks like you're going to be, there's a pretty healthy mix here. It's just going to be deciding which method you want to use. And if you have if you come across a problem like this where your denominators, your least common denominator is just going to be multiplying them by each other, that's essentially what you're doing in method 1. Method 1 is just cross multiplying because your lowest common denominator is the two denominators being multiplied together, okay? But you can see here 10p, right, is going to be a lowest common denominator. Here 10 will go into 10p if you multiply by p, 5 will go into it if you multiply by 2p, and then 5p by 2. So that is going to be a smaller number than multiplying all three of these together, okay? So it's just going to, you're just going to have to look at the denominators and see if there are like a least common multiple between them. Like here would be 4y, here would be 6r cubed. Okay, so these are going to be easy to see, but if you get numbers that aren't going to, let's see, this one I'm not really sure, I'd have to look at more, but this one you probably want to try to find. Actually, I would see about simplifying this left side first. Okay, so let me know if you have questions. The formative for all of these odds is up on Google Classroom for you to do as homework today. And then the evens will be up for tomorrow.